Do you think it is possible to survive in the middle of an icy plain with nothing but a shovel and the will to live? This seemingly impossible task was faced by thousands of pioneer families arriving on the American frontier. They found themselves alone in the wilderness, where winters were so harsh that the ground froze several feet deep and the winds encountered no obstacles in their path. They had no modern materials, no tools, and no ready-made plans. Their only resource was the land itself, which they had to transform into a reliable shelter from the elements. Watch the video to the end to find out what engineering tricks and forgotten technologies allowed them to build huts that did not freeze even in the most severe frosts. I will reveal to you a secret that was passed down from one settler to another and that cannot be found in architecture textbooks. The first thing that pioneers built was dictated not by comfort, but by desperate necessity. It was not so much the construction of a house as the creation of a barrier between the family and the harsh conditions. The time frame was extremely tight because the first snowstorm could be the last. Therefore, the very first shelters were not about beauty or convenience, but exclusively about preserving heat. They were the answer to the main question, how to survive the coming night. The initial instinct of the settlers was not to build on the ground, but to use the ground itself. The pioneers quickly realized that soil is an excellent natural insulator. At a depth of just a few feet, the temperature remained relatively stable throughout the year, without dropping to extreme sub-zero values. This simple physics formed the basis of the first dwellings, which literally grew out of the landscape. They were more like burrows than houses in the sense we are familiar with. The concept of borrowing heat from the planet was ingenious in its simplicity. Instead of building four walls open to the elements, the pioneers dug their dwellings into the side of a hill or on the bank of a river. This immediately solved the problem of three of the four walls, which were already insulated by tons of earth. All that remained was to erect the facade and cover the roof. This approach saved not only building materials, which were in dire shortage, but also precious time. This decision was also determined by the tools available. Many families who had just arrived after a long journey in a van had nothing but a shovel, an axe, and perhaps a pickaxe. With such a set of tools, it was impossible to quickly build a log cabin, but it was quite possible to dig a hole in the ground. The shovel became the main tool for survival. It allowed them to create a protected space using a minimum of imported resources. The first such shelter was often no more than a single room, where the family lived in incredible cramped conditions. But this crampedness was also part of the survival strategy. A small space required less firewood for heating, and the heat from a single hearth quickly filled the room. It was uncomfortable but effective. All household processes were subordinated to one goal, to conserve precious degrees of heat as much as possible. Such dwellings, known as dugouts or earthen huts, lacked any amenities. They were often damp and dark, but they served their main purpose. They provided a chance to survive the first most terrible winter. It was a starting point, a springboard from which it was possible to plan the construction of a more permanent and comfortable home. But it was these first burrows that allowed civilization to take root on the Great Plains. The settlers did not consider these dugouts to be something shameful. On the contrary, they were a source of pride, a symbol of their ability to adapt and survive. They proved that they could withstand the elements by using their own rules. This experience shaped their character, making them more resilient and resourceful. They learned to see the surrounding desert not as an enemy, but as a source of resources. This survival psychology formed the basis of all frontier architecture. The main principle was to use local materials, whatever they might be. If there were no trees around, but there was sturdy grass, they built with it. If there was only soil and clay, they used those. This flexibility of thinking was the key to developing vast territories. The ability to see potential in what lay underfoot was the main skill. The pioneers were not just farmers, they were self-taught engineers who reinvented construction. Their homes were a direct reflection of their surroundings. They did not fight nature, but integrated into it, becoming part of the landscape. These first shelters were temporary, but the lessons learned from their construction were invaluable. They taught the settlers the most important thing. The earth itself is the best insulator. They then applied this principle to their more permanent homes, whether turf huts or log cabins. We would love to hear your thoughts. What do you think was the most difficult part of building the first home on a blank slate? Write about it in the comments, and be sure to subscribe to our channel so you don't miss other stories about frontier exploration. What if I told you that everything you knew about pioneer homes wasn't entirely true? When we imagine the Wild West, we think of log cabins. However, on the Great Plains, where there wasn't a single tree for hundreds of miles around, the first and most common type of dwelling was the dugout, or dugout. It was not just a hole in the ground, but a well-thought-out engineering structure that obeyed the laws of thermodynamics. Choosing a location for it was the first and most important step. The ideal location was the southern or southeastern slope of a hill or ravine. This location offered several advantages. First, the slope already served as 3 walls and a roof, which radically reduced the amount of construction work. Second, the southern exposure allowed for maximum sunlight and heat to be captured during the short winter days, which helped to heat the dwelling. Third, the location on the slope ensured natural drainage of rain and meltwater. The construction process began with marking out the site. The family outlined the contours of the future room on the ground. The dimensions were modest, usually no more than 12 by 14 feet. Then the exhausting work with shovels began. The soil was removed and piled up nearby, as it would still be useful. They had to dig to a depth of 6 to 7 feet so that the ceiling would be high enough and the walls would be completely underground. The only wall that needed to be built was the front wall. It was constructed from whatever materials could be found. If there were stones nearby, they were laid on clay mortar. But more often than not, this wall was made of cut sod layers, which were laid like bricks. In this same wall, openings were left for the only door, and if lucky, one small window. The roof was the most difficult part of the construction. First, a central support beam was laid across a dug hole. Finding it was a stroke of luck. Often it was necessary to travel dozens of miles to the nearest river, where poplars or willows grew. Thinner poles were laid across this beam and covered with a layer of branches, tall grass or willow twigs. This frame was then covered with a thick layer of soil that had been dug out earlier, which was carefully compacted. And on top, they laid layers of turf with the grass facing up. Such a roof was incredibly heavy, but it had phenomenal thermal insulation properties. In winter, it was additionally covered with a layer of snow, turning the dugout into a real thermos. In summer, grass continued to grow on the roof, protecting the dwelling from the scorching sun. The floor in such a dugout was the simplest. It was just compacted earth. Sometimes it was moistened with water and sprinkled with ash, then tightly tamped down to a state almost like concrete. Over time, such a floor became very hard and even. To insulate it in some way, dry grass or homemade rugs were thrown on the floor. Heating was provided by a primitive hardened chimney. The chimney was most often made by digging a separate passage in the slope behind the back wall of the dugout. Sometimes it was laid out with stones or made of woven branches, covered with a thick layer of clay to prevent fire. This hearth provided heat, but also required a constant flow of air, creating drafts. The main problem with such dwellings was dampness. Groundwater, melted snow, and rain could seep through the walls and roof. To combat this, the pioneers tried to dig drainage ditches around their dwellings. Despite all its shortcomings, the dugout was incredibly warm in winter and cool in summer. Geothermal heat from the ground kept the temperature inside above freezing, even when a blizzard was raging outside. The hearth only heated the air to a comfortable temperature. It was the perfect solution for survival during the first winter. What detail of the dugout's construction do you find most ingenious? But even the dugout was only a temporary measure. In the next chapter, we will reveal the secret of houses built literally from grass, which turned out to be surprisingly durable. What I am about to show you was a construction technology that everyone thought was impossible until it became a reality. In the vast expanses of the Great Plains, where trees were a luxury, settlers turned their attention to the only material available in abundance, sod. They invented a house made of grass, which went down in history as the sod house. This technology was a unique response to the challenges of a hostile environment and is one of the most striking examples of human adaptation. The idea was simple. If the earth retains heat well in a dugout, why not build walls above ground out of it? But ordinary earth crumbled. The secret lay in using the top layer of soil, densely interwoven with the roots of tall prairie grasses, such as big bluestem or buffalo grass. These roots, intertwined over decades, created an incredibly strong, felt-like material that could hold its shape. Building soddy required a special tool, a heavy plow for breaking virgin soil. This plow cut the sod into long, even strips about a foot wide and 4 to 6 inches thick. It was important to choose the right time for cutting. This was usually done in the spring when the soil was moist but not too wet. This allowed the layers to remain intact. These long strips were then cut with an axe or shovel into blocks resembling large bricks, usually 2 to 3 feet long. These prairie bricks were surprisingly heavy, each weighing up to 50 pounds. Building a sod house was an incredibly labor-intensive process that required tremendous physical effort from the entire family. The walls were erected by laying these blocks in 2 or even 3 rows, as in conventional brickwork, with offset joints. The blocks were laid with the grass facing downwards, which allowed the roots to continue growing and bind the structure even more tightly. Sometimes a thin layer of clay was laid between the rows, but more often than not, the blocks were simply pressed tightly together. Their own weight and the strength of the roots held the walls securely in place. The thickness of such walls was impressive, from 2 to 3 feet. This made the soddy a real fortress. Such a wall had phenomenal thermal inertia. In summer, under the scorching sun, the inside of the house remained cool. In winter, such a wall did not freeze and perfectly retain the heat from the hearth, requiring much less fuel than a log house. Simple wooden frames were made in advance for window and door openings. They were installed during the wall construction process, and turf blocks were laid directly around them. Finding wood for these frames was a separate task, often requiring wood from the dismantled wagon in which the family had arrived. The sod roof was similar to that of a dugout. Wooden beams, if they could be obtained, or thinner poles were laid on the walls. On top of them went a layer of branches and grass, and then several layers of sod blocks which were laid at a slight angle for water drainage. Such a roof was very heavy and sometimes leaked, but it was completely windproof. The interior walls of such a house were simply uneven earth. To give them a neater appearance, they were often scraped smooth with a shovel. The walls could then be coated with clay or whitewashed with lime, if it could be obtained. Sometimes cloth or newspaper pages were hung on the walls to prevent the earth from crumbling. Despite their simplicity, sod houses were surprisingly durable. Some of them stood for decades, serving as homes for several generations. They were a symbol of an entire era of settlement in the Great Plains. This technology, born out of necessity, proved to be surprisingly effective and environmentally friendly, using only local and completely renewable materials. If you like how we reveal little-known facts about history, please support this video with a like. Are you ready for the shocking truth about the most famous house in the Wild West? The log cabin is strongly associated in our minds with the American frontier. However, in reality, it was not the most common type of dwelling, as it required a key resource that was not available on the Great Plains: forests. Such houses were built in the wooded foothills, in the Rocky Mountains, or in the eastern parts of the frontier, where trees were abundant. And on its own, without proper treatment, a log cabin was very cold. Construction began with the harvesting of timber. This was hard and dangerous work. The settler had to cut down dozens or even hundreds of trees, either alone or with the help of neighbors. Preference was given to straight, relatively even trunks of the same diameter, most often pine or spruce. The trees had to be cleared of branches and bark and then transported to the construction site, usually by oxen or horses. The foundation for the log house was simple. Usually large flat stones were laid at the corners of the future house. These stones lifted the house off the ground, preventing the lower logs from rotting due to contact with damp soil. Sometimes the foundation was made more solid by laying a continuous low wall of stones held together with clay mortar. The most difficult and responsible stage was laying the crowns and cutting the corner joints. The strength and warmth of the entire house depended on the quality of these locks. The simplest was the saddle-shaped lock, when semicircular notches were cut at the top and bottom of the log, into which perpendicular logs were placed. It was quick, but left large gaps. The dovetail or half-dovetail lock was considered more complex and of higher quality. Such a joint required great skill and precise calculation from the carpenter. However, it firmly fastened the logs together, preventing them from spreading apart, and created a tighter fit. The more precisely the joints were cut, the fewer gaps remained between the logs. During the construction of the walls, openings for future doors and windows were cut out immediately. This was done by sawing the logs to the required length. To prevent the wall from collapsing at the opening, vertical wooden slats were inserted into the ends of the logs to hold them in place. These same slats served as the basis for attaching door and window frames. The main problem with log cabins was the inevitable gaps between the logs. Trees are never perfectly straight, and when laid, gaps of several inches remain between them. Without careful sealing, the house turned into a sieve blown through by all the winds, which was impossible to heat in winter. This problem was so serious that the pioneers spent almost as much time filling the gaps as they did building the walls themselves. This process was called chinking or caulking. A perfectly constructed log cabin was not yet a house. It only became a house after the last gap had been filled. A log cabin was a symbol of a certain status. It showed that the settler had access to wood and, more importantly, the time and skills to build it. Unlike dugouts or sod houses, which were often temporary, log houses were built to last for decades. They were more spacious, brighter, and drier. But its thermal efficiency depended entirely on one critically important process that we often forget. A tree trunk, even a thick one, is not an ideal insulator on its own. Cold easily penetrated through hundreds of small and large gaps. What do you think was more difficult? Cutting down trees for a log cabin or cutting sod for a sod house? But the log cabin itself was cold. In the next chapter, you will learn how the pioneers solved the main problem of log walls. The process of sealing a log cabin, known as chinking, was a vital step in transforming a drafty frame into a warm dwelling. It was a separate technology that required its own materials and skills. If corner joints were the skeleton of the house, then chinking was its skin, protecting it from the cold. Without high-quality sealing of the gaps, all the efforts of cutting the logs would have been in vain. The settlers knew that the devil was in the details, and in their case, in the gaps. The process itself consisted of two stages: filling large gaps and then plastering. First, the large gaps between the logs had to be filled with something. Any available materials were used for this purpose. These could be wood chips and pieces left over from construction, dry moss, which grew in abundance in wooded areas, or even twisted bundles of dry grass. This filler was tightly packed into the gaps, creating a base for the ceiling layer. Then a special mortar, or daub, was prepared. The most common recipe included clay, water, and a binding agent. Straw, dry grass, and sometimes even wool were used as binding agents to reinforce the mortar and prevent it from cracking as it dried. The clay was soaked and thoroughly mixed with the filler until a thick plastic mass was obtained. This mortar was carefully rubbed into the cracks on top of the filler by hand. The work had to be done quickly before the clay dried. The pioneering craftsmen tried to make this layer as dense and smooth as possible so that it would not let air or moisture through. Sometimes the mortar was applied in several layers, allowing each previous layer to dry slightly. In some regions where clay was unavailable, other recipes were used. For example, a mixture based on lime, sand, and hair could be used. Such a solution was more durable and better resisted moisture, but lime was an expensive and rare material on the frontier. Therefore, most people were content with simple clay. After drying, the clay plaster became as hard as stone. It tightly sealed all the cracks, turning the four walls into a monolithic structure. The house immediately became noticeably warmer and quieter. The drafts that used to blow through the rooms disappeared. Now the heat from the hearth remained inside and was not blown outside. However, this method had one significant drawback. It required constant maintenance. A wooden log house breathes and settles during the first few years. The logs dried out, deformed, and new cracks appeared in the clay plaster. Every year, usually in the fall, before the onset of cold weather, the owner of the house had to carry out an inspection. The repair process was simple. The old, cracked clay was scraped out, and the cracks were filled with fresh mortar. This was a mandatory part of preparing for winter, just as important as stocking up on firewood. The comfort of wintering depended directly on the thoroughness of this work. In some cases, if the settler was wealthy enough, he could afford a more advanced method. The cracks were caulked with tarred hemp or tow, as was done in shipbuilding, and the gaps could be covered with thin wooden slats on top. But this was a rarity, available to few. For most families, clay, straw, and their own labor were the only tools in the fight against drafts. This technology, simple and dirty, was as important to survival as an axe or a gun. It demonstrates how complex the task of building a warm house was. What if I showed you a time machine that would take us to the roof of a pioneer house? Once the walls were erected and sealed, the settler faced two new tasks: insulating the dwelling from the cold ground and protecting it from precipitation and heat loss through the top. The construction of the floor and roof was no less important for heat conservation than the walls themselves. Any mistake here would negate all previous efforts. Let's start with the floor. In the earliest and poorest huts, there was no floor as such. As in dugouts, it was simply compacted earth. Such a floor was cold and dusty. To make it somewhat more civilized, it was periodically moistened and swept. And for warmth, it was covered with dry grass, reed mats, or homemade rugs. A more advanced and desirable option was a wooden floor, but boards were an incredible luxury on the frontier. If there was no sawmill nearby, which was usually the case, the pioneers had to make them by hand. It was hellish work, requiring the logs to be cut with a two-handed saw. Most often, settlers chose a compromise option, the so-called pan-shin floor. To make it, they took thinner logs, split them in half, and laid them on the earthen foundation with the flat side up. The gaps between these half logs were also filled with clay or moss. Such a floor was uneven, but it was wooden, which was already a huge step towards comfort. It blocked out the dampness and cold coming from the ground. Now about the roof. The construction of the roof began with the installation of rafters. In log houses, these were the same logs, only thinner, which were laid at an angle to ensure water drainage. In turf houses, this was the most scarce part, requiring long and strong poles which often had to be purchased and transported from afar. Lathing was laid on the rafters, thinner branches or poles that served as the basis for the roofing. In wooded areas, the best but most labor-intensive covering was wooden shingles or shakes. The shingles were cut from cedar or pine and laid in rows, overlapping like scales. Such a roof was light, durable, and provided excellent protection from rain. However, on the plains where sod houses were built, the most common roofing material was turf. A layer of tall grass or branches was laid on top of the lathing, followed by layers of turf, as on the walls. Such a roof was very heavy and required strong rafters, but it had excellent thermal insulation. In winter, it was covered with snow, and heat loss through the top was minimal. Sod roofs had their drawbacks, the main one being that they often leaked. During heavy rains, water seeped through the layer of soil. Housewives had to place buckets and basins throughout the house. But in terms of warmth in winter, it was one of the best options. Inside the house, under the roof itself, an attic or loft was often arranged. It was made by laying floor beams and covering them with boards or the same pancini. This space not only served as storage, but also played an important role in heat exchange. It created an additional air layer between the living room and the cold roof. Often, sleeping places were arranged in this loft. It was the warmest place in the house, as all the hot air from the hearth rose there. Thus, the floor and roof construction was not just a shell, but an active heat-saving system that used every available material and physical law. Which of these methods do you think is most practical for those conditions? But neither the floor nor the roof made sense without a heat source. In the next chapter, we will look at the very center of the pioneer house. The center of any pioneer dwelling was the hearth. It was not only a source of heat, but also of light on dark evenings, as well as a place for cooking. Its design and efficiency determined whether the house would be warm or smoky and cold. Building the hearth and chimney was one of the most important stages, requiring special attention to detail and fire safety. The location for the hearth was chosen first. It was usually placed against one of the end walls of the house. This allowed the chimney to be let outside without disturbing the structure of the roof in its central part. The hearth was made large, capable of accommodating large logs and several pots. The whole life of the family literally revolved around this source of fire. The foundation for the hearth and chimney was made of the largest and strongest stones. The structure was very heavy and required a solid foundation so that it would not settle over time and cause cracks. If there was an abundance of stones, the entire hearth and chimney were laid out of them, fastened with clay mortar. This was the best and safest option, but it was not available everywhere. On the Great Plains, where stone was as scarce as wood, pioneers had to improvise. This is where the technology of the so-called cat chimney was born. It was a woven structure that became a symbol of ingenuity and desperation. First, a frame of the desired shape was woven from strong sticks and rods. Then this woven frame was coated with several thick layers of a mixture of clay and straw or grass. The clay was applied both inside and outside, creating a thick crust. After drying, this structure became surprisingly strong and fireproof. The clay baked in the heat and turned into a kind of ceramic. Of course, such a chimney was extremely fire hazardous. Over time, the clay cracked, and sparks could fall onto the wooden frame. The pioneers had to constantly monitor the condition of the chimney, regularly coating it with fresh clay. Sometimes the inside of the frame burned out, but the baked clay continued to hold its shape. The firebox, or fireplace, was where the fire burned. They tried to build it out of stones, or, as a last resort, the same turf that burned poorly. The back wall of the firebox was often made sloped so that it would reflect more heat into the room rather than release it directly into the chimney. It was a simple but effective solution for increasing efficiency. The efficiency of the hearth was low. Most of the heat, according to various estimates up to 80%, escaped into the chimney along with the smoke. But the pioneers had no choice. An open fire was the only available means of heating. To compensate for this inefficiency, it was necessary to stockpile huge amounts of firewood. The smoke damper, or damper, was an important detail. It was a simple metal or wooden plate that allowed the draft in the chimney to be regulated. When the fire burned brightly, it was opened, and at night, when only embers remained, it was closed to keep the precious heat in the house and prevent it from escaping through the chimney. Over time, cast iron stoves began to replace open hearths. They were many times more efficient, required less wood, and provided more heat. But a stove was an expensive industrial product that had to be purchased and transported hundreds of miles. For many families in the early years of frontier life, a homemade hearth made of clay and stones remained the only option. Despite all its shortcomings, the hearth was the center of the universe for pioneer families. They warmed themselves by its fire, cooked their meals, repaired their tools, and spent long winter evenings there. It was a symbol of home and civilization in the middle of the wild and cold prairie. In the battle for warmth, every element of the house mattered, but windows and doors were the main points of vulnerability. Any opening in the outer wall is a potential bridge for cold and drafts. Pioneers intuitively understood this, so their houses had a minimum number in size of openings. Light and convenient entry were sacrificed for warmth. It was a harsh compromise dictated by the conditions of survival. Windows in the first dwellings, whether dugouts or sod houses, were a real luxury. If they existed at all, they were very small, no larger than a handkerchief. A large window would have meant enormous heat loss, which could not be compensated for by a primitive hearth. Therefore, rooms were often dimly lit, illuminated only by the fire in the fireplace and the light coming from the open door. Glass was one of the most expensive and scarce materials on the frontier. It had to be transported from far away and was easily broken during transit. Few could afford a real glass window. Therefore, pioneers looked for a substitute that would let in at least a little light while protecting from the wind and cold. The most common solution was oiled paper or cloth. They took a sheet of thick paper or a piece of thin canvas and carefully soaked it in fat, usually animal fat or linseed oil. After drying, the material became translucent and waterproof. It was stretched over a simple wooden frame and inserted into the window opening. Of course, such a window did not let in much light and was opaque, but it fulfilled its main function. It blocked the wind and snow while letting in enough light to distinguish objects. In winter, such windows were often covered with a second layer or simply plugged from the inside with rags or straw for additional insulation. Doors were also an area of increased attention. They were made of thick boards tightly fitted together. The most common design was the batten, several vertical boards fastened with cross and diagonal slats. Such a door was heavy and durable. It was hung on simple leather or wrought iron hinges. The main task was to ensure that the door fit tightly against the jamb. Gaps around the perimeter were as much a source of cold as holes in the walls. Anything at hand was used for sealing. Strips of fabric, felt, or even fur were nailed to the edges of the door or frame. This created a seal that blocked drafts. Often, massive wooden shutters were installed outside the house, above the door and windows. At night or during heavy snowstorms, they were closed tightly, creating an additional barrier against the cold. These shutters were not for beauty, but for survival. They turned the house into an airtight fortress. In later and more affluent homes, a so-called storm vestibule, or simply a porch, was sometimes built. It was a small, unheated extension in front of the main door. It created an airlock. A person would first enter the vestibule, close the outer door behind them, and only then open the inner door. This simple solution prevented cold air from rushing directly into the living quarters. One of the key elements mentioned in our topic was the underfloor with earth, or, as it was more often called, the root cellar. This structure was no less important for survival than the roof or the hearth. It performed two critically important functions at once: preserving food supplies and passively regulating the temperature of the dwelling itself. The pioneers used the same principle as in the construction of dugouts: the stable temperature of the earth. There were two main types of such cellars. The first was a separate cellar dug outside the house. It was usually dug into a hillside or simply into the ground and covered with a sturdy roof made of logs and turf. This type of cellar was ideal for storing large quantities of vegetables, as it maintained a constant cool temperature and high humidity. The second type, which interests us more, is the subfloor or cellar, dug directly under the floor of the hut. Access to it was through a hatch cut directly into the floor of the room. This option was especially popular in log cabins, where there was at least some wooden flooring, or even in sod houses with earthen floors. The process was simple. A pit of the required size was dug in the center of the room, sometimes covering the entire area of the house, but more often only in one part of it. The walls of the pit could be reinforced with boards or stones to prevent the soil from crumbling, but often they were left simply earthen. The hatch at the top was tightly closed so as not to interfere with movement around the room. The main function of such a subfloor was, of course, to store food. While it was freezing outside and the ground was frozen, the temperature in the cellar remained a few degrees above zero. This allowed potatoes, carrots, cabbage, and other root vegetables to be stored throughout the winter without freezing or rotting. But this subfloor had a second, equally important thermal function. It worked as a geothermal accumulator. The ground under the house, separated from the frost by walls and a roof, had a stable positive temperature. This huge mass of soil under the floor served as a thermal cushion. The earthen floor of a hut without a subfloor was in contact with the frozen top layer of soil. But a floor with a deep cellar underneath was in contact with air that was at a stable positive temperature. This significantly reduced heat loss through the floor. The cold could not penetrate so actively from below. Moreover, during the most severe frosts, the hatch to the crawl space could even be opened slightly. Warmer and more humid air from the cellar entered the room, helping to maintain the temperature and humidity. It was a simple but effective system of passive geothermal heating support. The very fact of having a wooden floor above such a crawl space already made life much more comfortable. The floor was not icy, and you could walk on it. The crawl space cut off not only the cold, but also the dampness coming from the ground, making the air in the house drier than in the dugout. Thus, the subfloor was not just a storage room. It was an important element of the house's engineering system. It integrated the dwelling into the ground, using its stability to combat the unstable and hostile climate on the surface. This was further proof that the pioneers thought of their homes as a single system. For a settler whose harvest was his only guarantee of survival until spring, such a cellar was invaluable. It protected the fruits of his labor from the main threat, frost, At the same time, it helped make his own home a little warmer and more comfortable. Even a perfectly built and sealed house required additional tricks to survive the coldest months. Pioneers developed a whole set of household techniques and tricks that helped to preserve precious heat. These methods concerned both the interior design and additional insulation of the house from the outside. One of the most effective techniques was banking the house. In late autumn, before the first frosts, the owner would take a shovel and begin to bank his house. He would pile earth, turf, dry leaves, or straw against the outer walls. Sometimes a simple wooden frame was built for this purpose, to hold the insulating material in place. This layer, several feet thick, completely covered the lower part of the house and the foundation, sometimes reaching up to the windows. In winter, snow fell on top of this mound, creating an almost impenetrable barrier to the cold. This prevented the wind from blowing heat out from under the floor and through the lower crowns of the log house. Such embankment was temporary, and in the spring it was removed so that the walls could dry out. Inside the house, life was also organized with heat conservation in mind. All the furniture was simple, homemade, and mobile. At night, the table and benches were moved closer to the hearth, creating a cozy and warm microclimate. People slept either in the loft, where all the warm air rose, or in beds that were also close to the fire. The beds were often high so that people could sleep away from the cold floor, which was always drafty. Sometimes heavy curtains were hung around the beds, or even a canopy was made. This created a small enclosed space that quickly warmed up with the heat of the sleeping people and retained it longer. Textiles played a huge role in keeping warm. Anything that could be used was put to good use. Homemade patchwork quilts, quilted bedspreads, and animal skins were used for more than just sleeping. Heavy blankets could be hung on the walls, especially on the north wall, which was the coldest, creating an additional layer of insulation. Floors, even if they were wooden, were covered with homemade rugs and mats. They were woven from rags, old clothes, or made from reeds. This was not so much for beauty as to block drafts coming from cracks in the floor or under the door. Each such rug was a small victory in the fight against the cold. The interior space of the house was often divided into zones with heavy curtains. For example, the sleeping area could be separated from the rest of the room. This made it possible to heat the part of the house where people spent most of their time more efficiently, without wasting firewood on heating corners that remain cold anyway. Even something as simple as cooking contributed to this. Long processes, such as baking bread in the oven or cooking soup, filled the house with warmth and moisture. In winter, the hearth worked almost around the clock, sustaining life in the house. All these seemingly small things, wall insulation, patchwork quilts, rugs on the floor, and curtains, worked together as a single system. They complemented the structural features of the house, such as thick walls and an earthen subfloor. It was a daily, painstaking effort to retain heat. The pioneers' success was not due to anyone's secret, but to this comprehensive approach. They used geothermal heat, thick walls, ceiling, proper orientation of the house, and many household tricks. It was this combination of engineering and household ingenuity that allowed them to survive and build a life in conditions that seem impossible to us today. We can see that the survival of the pioneers on the American frontier was not a miracle, but the result of incredible ingenuity and hard work. Their homes, whether dugouts, sod houses, or log cabins, were true engineering masterpieces born out of necessity. They did not have modern insulation, but they skillfully used what the earth itself gave them: turf, clay, wood, and even cold soil, turning it into a source of heat. These people rediscovered the principles of thermal insulation, thermal inertia, and passive geothermal heating. They proved that the human mind is capable of finding solutions in the most seemingly hopeless situations. Each house was not just a shelter, but a well-thought-out system where the thickness of the walls, the construction of the roof, the location of the hearth, and even the subfloor worked toward a common goal: to preserve life. Their legacy is not only the history of the continent's exploration, but also an important lesson about the importance of understanding nature and working with it rather than against it. They built houses that did not freeze because they were part of the landscape itself. What other aspects of life and survival on the American frontier would you like us to cover? Perhaps you are interested in how they obtained water, how they preserved food without refrigerators, or what tools they used. Suggest topics for future videos that you would like to see on our channel in the comments. And don't forget to subscribe so you don't miss new episodes.